so let's go through trigonometry also. Okay, in general, a trigonometric functions is in this form: y equal to a something. So the something here will be the trigonometry. Okay, it will be the trigonometry. It can be sine or cos or tangent. Then the angle bx plus c, then minus d. Okay, so let's say for example, you have y equal to a sine bx plus c, then let's say plus d. I put plus for everything. Okay, so let's see the a over there. So what they say is a is the changes in amplitude. Changes in amplitude. So for example, you have sine graph. Okay, this is the sine graph. The basic sine graph is just y equal to sine x. So now we have number in front. So if you have number in front, in general I call it a. So basically it affects the amplitude. Amplitude is here to here. That is the amplitude. It affects the amplitude. So if let's say this is 2, then they will go all the way to 2. So the mountain will be taller. And then here the valley will be steeper. Going down more until -2. Okay? So that is the effect of the amplitude. Now let's say one example. I put y equal to sine x, then I put y equal to 2 sine x. So we build up slowly on all this transformation. Okay, so sine x is going to be like this: 1 minus 1, and here is going to be 360 degree. Okay, so now if you have 2 sine x, it goes up by 2 units and goes down by 2 units. So this is going to be 2, and the minimum is going to be -2. This is 360. Okay, so now we look at the next one. B, increase the number of cycles. Increase the number of cycles. And C, alter x-axis by -c. Okay, so D, alter y-axis by D. Okay, now let's see more example. If I have y equal to sine 2x, so this is where it increase the number of cycle. So it increased the number of cycle into 2 cycles. In 360 degree, it has to make 2 cycles. In other words, in 180, it makes 1 cycle followed by another cycle. Okay, let me make it. Like this. So the amplitude is not affected. It's still 1 and -1. And then the cycle, you can see 2 rounds over there. So that is the effect of B. Whereas the effect of C, let's say example, y equal to sine x minus 90 degree. As you can see, they say alter x-axis by -c. So the effect is opposite. If this is positive c, here the effect is -c. So if this is -90 degree, then the effect is positive 90 degree. So which means they will go to the right by 90 degree. Okay, so it's opposite one. If -90, then you think of positive 90 is to the right. Okay, so let's see how. This is the graph. let's start from the basic graph here, where you have to know that 90 degrees is here. 90 degrees here is where the graph reached the maximum. Okay, now 90, 180, 270, 360. So 90 degree is where the graph start to turn and then go down, and then from minimum, and then no more already. Okay, no more already. After it reached here 360, then it reached at the minimum and no more. So we have to draw out accordingly on the other side. So it is going to be like this: 1 and minus 1. So what am I trying to say is it goes to the right by 90 degree. So you start at 90 degree and just draw the sine graph accordingly. And for the rest, for the graph before it, you can just join up accordingly. Okay, so that is the graph of 90 degree. And after that, the D in front. The D here, it's a fact, it alters the y-axis. That means the graph will either go up or down. Depends on whether it's positive or negative. Positive, it goes up. Negative, it goes down. Okay, so example, if I have y equal to sine x plus 1, and then what happens is the whole graph go up by 1 unit. 0, 1, 2. So like this, go up, go down, and like that. So this is 180 degree. This is 360 degree. So the graph is like this then. So what you can see here is the whole graph go up by 1 unit. Okay. Here I just show the effect of the individual, individual A, B, C, and D. So this is just what happens when A is there, what happens when B is there, and what happens when C is there, and then what happens when D is there. I show one by one. But sometimes, the question will put A, B, C, D all together. So in that case, right, my suggestion, use calculator. Because we need more techniques to be explained. If you don't use calculator, then there are certain things to concern about, where in our syllabus I don't recommend to care about that. So use calculator. So let's say, for example, if you have y equal to 2 sine, okay, let's say 3 sine 2x minus 180 degree plus 4. Let's say something like this. Okay, where the effect of A is there, the effect of B is here, the effect of C, the effect of D. There are certain things to concern one. You need to factorize the two, and then you need to do something. So we don't want to discuss about that issue. So my suggestions, just use calculator. So how to use calculator? Of course, we build a table. We build a table like this. So what am I trying to say is, if A, B, C, D come alone, then you can use transformation. If A, B, C, D all come together, using this will be faster at the end. We build a table like this, and then draw a line. Okay, then we have calculator to key in. Okay, so first, when you key in, right, you key in the whole thing: 3 sine 2x minus 180 close bracket and plus 4. Okay, then you press calculate, right? You put 0, so you get 4. Then you put 90, you get 4. You put 180, you get 4. You put 270, you get 4. You put 360, you get 4. Okay, so when you get something like that, that means we don't have enough information to draw the graph. So we need more angle. I put another column. Obviously, if you put 4, 4, 4, 4, you may feel like, oh, is that going to be a straight line? So of course no, right? So I put more information. Okay, I put angle in between. 45, 135, 225, 315. Okay, so I put 45. I get 1. I put 135. I get 7. I put 225. I get 1. I put 315. We get 7. Okay, then let's sketch the graph. Okay, so I'm going to change the horizontal axis. I bring it down. As I know we don't have negative value. 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. Y and X. Okay, so we have 0, 4. Okay, let's say 45, 90, 135, 180, 225, 270, 315, 360. Okay, then 45 we get 1. Then we get 90. 135 we get 7. 180 we get 4. 225 we get 1. 270 we get 4. And we get 7. Then we get 4. Okay, we draw the graph. Okay, so here is where we get the graph. Okay, now that is the graph. So like what I said, when A, B, C, D come together, instead of considering transformation one by one, it is better to use calculator, build a table and sketch the graph. That is more safe. Okay, we move on. We have 5.2 cosine graph. Okay, so as you can see, cosine graph, basically it starts from maximum, go all the way down to minimum at 180 degree or pi. Then after that, it goes back up to maximum again at 2 pi or 360. Okay, so on this page, you have a tangent curve. So let's take a look. Tangent, start from origin. It goes all the way up and parallel with this vertical line. This is called vertical asymptote. So it parallel with the vertical asymptotes at pi over 2 or 90 degree. And then you can see the graph start from the bottom where it is initially parallel with the asymptotes also. And it goes up at 180 degree. It intersects the x-axis. And it goes up again and parallel with the asymptote at 270 degree or 3 pi over 2 radian. And then again, the graph starts from the bottom where initially it is parallel with the vertical asymptote, and then they reach 360 degree, and let's say we just stop here for our discussion. Then the rest, of course the rest you just join out accordingly, like here before it, we just join out like that. So you can see the period is 180 degree. Every 180 degree you can see this form. 180 degree, you can see that form again, this kind of graph. So that is tangent graph. Okay, now let's move on. 5.4 when sine, cos, and tangent are positive. So this is about the 4 quadrant. So the first quadrant is where all means sine, cos, tangent, they are all positive. When the theta is acute angle, sine, cos, tangent are positive. Okay, so sine positive, cos positive, tangent positive. Now when it comes to obtuse angle in second quadrant, we use 180 minus theta to find the obtuse angle. And then you can see in this second quadrant we use S. S means sine is positive. How about cos and tangent? So they are actually negative. Okay, then you can see the next quadrant, third quadrant. We use 180 plus theta to find the angle in third quadrant. And then you can see T over here. So if you can see T here, it means only tangent is positive. So sine is negative, cos is negative, tangent is positive. Okay, next one. If you see C here, that means cos is positive, sine and tangent is negative. And we use 360 minus theta to find the angle. Okay, and then after that, I will give example later on how to apply this. So let's finish off the theory first. 5.5, the identities, that means the formula. So we have tangent theta equal to sine theta over cos theta. Then we have sine square theta plus cos square theta equal to 1. So these are the two trigonometry identity that we need to care about. Okay, let's see one example first. Okay, let's see one example. Show that the equation tangent x plus sine x over tangent x minus sine x equal to k, where k is a constant, may be expressed as 1 plus cos x 1 minus cos x equal to k. So how we do it? Let's see. They give tangent x plus sine x over tangent x minus sine x equal to k. So in order to get that, our concern here is the tangent has become 1. Okay, tangent has become 1. Sine has become cos. So tangent become 1. That is a bit obvious. We can divide by tangent up and down. Divide by tangent x, divide by tangent x. So let's do that. So we have tangent x over tangent x plus sine x over tangent x. At the bottom, tangent x over tangent x, sine x over tangent x equal to k. So tangent x over tangent x is 1. Sine x over cos x. So first we need to know tangent is sine over cos. So when I divide by sine over cos, that means we multiply with cos over sine. So again, the denominator, tangent over tangent is 1. Sine over tangent is sine multiplied with cos over sine. Then we can cut the sine. Okay, then we will get 1 plus cos x 1 minus cos x equal to k. So we get what we're supposed to show, and then we continue. We look at B. Hence express cos x in terms of k. So we continue from our result just now. We want to find cos x in terms of k. I'm going to bring the denominator to the other side. Then I multiply with k. Then I gather up all the cos terms to the on the left hand side. Then I factorize the cos x. Then I get cos x equal to k minus 1, k plus 1. Okay, I get this cos in terms of k. Now C. Hence solve the equation. Okay, so they give tangent x plus sine x, where we already simplify a lot. So we already simplify tangent x plus sine x, tangent x minus sine x to this form in part 1. Okay, we already simplified it in part 1. We simplified it to 1 plus cos, 1 minus cos. So let's make the same thing happen here. 1 plus cos x, 1 minus cos x equal to 4. Equal to 4. So after that, based on this result also, we also simplify our cos x equal to k minus 1, k plus 1. For our case, k is 4. So 4 minus 1, 4 plus 1. So we simplified it to this form already. Cos x is equal to 3 over 5. Now cos x equal to 3 over 5. And we need to inverse cos now. Inverse cos 3 over 5. So based on the ASTC that we learned just now, in radian, of course, we are going to take x, pi minus x, pi plus x, 2 pi minus x. Okay. And our cos x is positive. So you know that cos is positive at first quadrant and fourth quadrant. So what to do is, now we press calculator. We change our calculator to radian mode. Then you press inverse cos 3 over 5. Then you will get 0.927. I purposely leave some space in front because I know that they take until negative pi. So we may have some negative angle in front. So we will discuss on how to find that afterwards. So we know that it is going to be the acute angle 0.927 and the fourth quadrant. Fourth quadrant is 2 pi minus x. For sure it is over pi already, but I just find it out first. So the other angle in the fourth quadrant is 2 pi minus 0.927. Okay. So that is the angle in first quadrant and fourth quadrant. But the thing is, the angle in fourth quadrant is already more than pi. So this is not acceptable. Okay. This is not acceptable because it's more than the interval already. Okay. Then we also have negative angle. And how to find negative angle? You just take these two basic angle, you plus 2 pi. If they want a bigger positive angles, you plus 2 pi. Okay. If they want negative angle, you take your two basic answer here, you minus 2 pi. Okay. So which means you minus 2 pi if you want any negative answer. You plus 2 pi if you want more positive answer. In terms of degree, we plus 360 degree, or you minus 360 degree. So over here, I'm going to find out the negative angle. I'm going to take the angle in the fourth quadrant, I minus with 2 pi, then I will get negative 0.927. So this is still within the interval. So at the end, we have two answers. So negative 0.927 and positive 0.927.